Do you want to successfully complete the D686 Objective Assessment exam? Then you are in the right place. Our website provides a list of questions and answers for your success in the D686 OA exam for free. We understand that acing your OA exam can be quite challenging. That's why we provide completely free exam guides and practice questions for you. In this video, we will cover questions from memory management, file systems, process scheduling, process synchronization, and system virtualization. So let's get started. 1. A web server experiencing sudden traffic spikes during holiday sales needs to rapidly scale resources up and down. Which operating system characteristic best addresses this requirement while maintaining cost efficiency? A. Process synchronization. B. Virtual memory management. C. Resource elasticity. D. Interrupt handling. Can you guess the answer? Correct answer, C. Resource elasticity. Explanation: option C is correct because resource elasticity allows dynamic allocation and deallocation of computing resources based on demand. Perfect for handling variable workloads while optimizing costs. Option A is incorrect because process synchronization manages concurrent access to shared resources, but doesn't handle dynamic scaling of system resources for variable workloads. Option B is incorrect because virtual memory management extends available memory through disk storage, but doesn't address the need for scaling computational resources. Option D is incorrect because interrupt handling manages hardware and software events, but doesn't provide the capability to scale resources based on demand. Alright, let's dive into the core concept behind resource elasticity in operating systems. When we talk about a web server handling holiday traffic spikes, we're really discussing how modern operating systems can dynamically adjust their resource allocation. Think of it like a rubber band that stretches when you need more resources and contracts when demand drops. Resource elasticity allows the OS to automatically scale CPU, memory, and storage resources up during Black Friday sales when thousands of users are shopping, then scale back down at night to save costs. This is different from process synchronization, which just manages access to shared resources, or virtual memory, which extends RAM using disk space. The key here is the dynamic, automatic adjustment based on real-time demand. 2. Your application crashes frequently when multiple users access the same database records simultaneously. What fundamental operating system concept should be implemented to prevent this issue? A. Memory paging. B. Mutual exclusion. C. Device drivers. D. File compression. Do you know the answer? Correct answer, B. Mutual exclusion. Explanation: option B is correct because mutual exclusion ensures only one process can access a critical section at a time, preventing race conditions and data corruption in concurrent environments. Option A is incorrect because memory paging manages virtual memory by dividing it into fixed-size blocks, not preventing simultaneous access to shared resources. Option C is incorrect because device drivers facilitate communication between hardware and software, but don't manage concurrent access to shared data. Option D is incorrect because file compression reduces storage space requirements, but has no role in managing concurrent access to database records. To really understand why mutual exclusion is the correct choice, let's explore the theory behind preventing database crashes. When multiple users try to modify the same database record simultaneously, we have what's called a race condition. Imagine two bank tellers trying to update the same account balance at the exact same moment. Without mutual exclusion, both might read the original balance, make their changes and write back, causing one transaction to be lost. Mutual exclusion acts like a lock on a bathroom door. Only one person can use it at a time. This ensures that when one process is accessing the critical section, which is the database record in our case, no other process can interfere until the first one completes. 3. A video editing application becomes unresponsive while rendering large files, freezing the entire user interface. Which threading model would best prevent this problem while maintaining performance? A. Single-threaded execution. B. Many-to-one model. C. One-to-one model. D. Cooperative threading. Can you guess the answer? Correct answer, C. One-to-one model. Explanation. Option C is correct because the one-to-one model maps each user thread to a kernel thread, allowing true parallelism and preventing one thread from blocking the entire application. Option A is incorrect because single-threaded execution would cause the entire application to freeze during intensive operations, exactly the problem being experienced. Option B is incorrect because the many-to-one model maps all user threads to one kernel thread, causing the entire process to block. Option D is incorrect because cooperative threading requires threads to voluntarily yield control, which wouldn't help when a thread is busy rendering. This is a critical concept for the exam, so let's dig into the principle behind threading models. The one-to-one threading model is perfect for preventing application freezes because it maps each user thread directly to a kernel thread. Think of it like having multiple checkout lanes at a grocery store instead of just one. When your video editor renders a large file, that's one thread doing heavy work. With the one-to-one model, the user interface runs on a completely separate kernel thread. This means even if the rendering thread is completely busy, the UI thread can still respond to your clicks and commands. It's true parallelism, not just the illusion of it. 4. A cloud storage system needs to distribute files across multiple servers while appearing as a single unified storage space to users. Which file system concept enables this functionality? A. File fragmentation. B. Virtual file system. C. File compression. D. Sequential access. Do you know the answer? Correct answer, B. Virtual file system. Explanation. Option B is correct because virtual file systems provide an abstraction layer that allows multiple different file systems to appear as one unified interface to applications. Option A is incorrect because file fragmentation refers to files being stored in non-contiguous blocks, which actually decreases performance rather than enabling distribution. Option C is incorrect because file compression reduces file size for storage efficiency, but does not enable distribution across multiple servers transparently. Option D is incorrect because sequential access is a method of reading files in order, but does not relate to distributing storage across servers. Let's explore the theory behind virtual file systems to see why this is the perfect fit for cloud storage. A virtual file system, or VFS, is like a universal translator for different storage systems. Imagine you have files stored on multiple servers using different file systems. Maybe some use NTFS, others use ext4, and some use a proprietary cloud format. The VFS sits between your applications and these various storage systems, presenting a single unified interface. Your applications don't need to know or care about the underlying differences. They just see one big storage space, even though behind the scenes the VFS is managing the complexity of multiple servers and file systems. 5. An autonomous vehicle system requires guaranteed response times for brake commands within strict time constraints. Which type of operating system architecture is most suitable for this application? A. Batch processing system. B. Time-sharing system. C. Real-time operating system. D. Distributed computing system. Can you guess the answer? Correct answer, C. Real-time operating system. Explanation. Option C is correct because real-time operating systems guarantee response times within specified deadlines, which is critical for safety systems like automotive braking, where timing is essential. Option A is incorrect because batch processing systems execute jobs sequentially without user interaction, making them inappropriate for immediate response requirements in vehicle control. Option B is incorrect because time-sharing systems focus on fair resource allocation among users but don't guarantee strict response time requirements. Option D is incorrect because distributed computing systems spread computation across networks but don't inherently provide the guaranteed timing constraints needed for real-time control. Understanding real-time operating systems is crucial for safety-critical applications like autonomous vehicles. An RTOS guarantees that certain operations will complete within strict time bounds. We call these hard deadlines. When a car's sensor detects an obstacle, the brake command must be processed within milliseconds, not whenever the CPU gets around to it. Unlike general-purpose operating systems that try to be fair to all processes, an RTOS prioritizes time-critical tasks absolutely. Think of it like an emergency room. When a critical patient arrives, they don't wait in line, they get immediate attention. This deterministic behavior is what makes RTOS perfect for automotive, aerospace, and medical devices. 6. A server administrator notices certain processes consuming excessive CPU time, while others starve for resources. Which scheduling algorithm would best ensure fairness while preventing indefinite waiting? A. First come, first served. B. Shortest job first. C. Round-robin scheduling. D. Last in, first out. Do you know the answer? Correct answer, C. Round-robin scheduling. Explanation: Option C is correct because round-robin scheduling allocates fixed time quanta to each process in circular order, ensuring all processes receive CPU time and preventing starvation. Option A is incorrect because first come, first served can lead to long processes monopolizing CPU time, causing starvation for subsequent shorter processes. Option B is incorrect because shortest job first can cause starvation for longer processes, as shorter ones continuously arrive and get priority. Option D is incorrect because last in, first out isn't a standard CPU scheduling algorithm and would cause unfair treatment of earlier processes. The I/O scheduler is the traffic controller for your system's data highways. When multiple processes request I/O operations simultaneously, like our streaming service needing video packets while background downloads run, the I/O scheduler decides who goes first. You can run Windows, Linux, FreeBSD, or any OS that supports your virtual hardware, completely unmodified. The guest operating systems don't know they're virtualized. They think they're running on real hardware, unlike first come, first served, where a long process blocks everyone. Or shortest job first, where long processes might never run. Round-robin guarantees everyone gets regular CPU time. It's democratic scheduling at its finest. 7. During system boot, the operating system needs to load essential components in a specific sequence to establish core functionality. What architectural pattern best describes this initialization approach? A. Monolithic structure. B. Layered architecture. C. Peer-to-peer model. D. Client-server pattern. Can you guess the answer? Correct answer, B. Layered architecture. Explanation: Option B is correct because layered architecture organizes system components hierarchically, where each layer depends on services from lower layers, ideal for sequential initialization during boot. Option A is incorrect because monolithic structure combines all functionality into a single large program without the organized sequential loading pattern described. Option C is incorrect because peer-to-peer model involves equal nodes sharing resources, not applicable to the hierarchical boot sequence requirement. Option D is incorrect because client-server pattern describes request-response interactions between processes, not the structured initialization sequence during system boot. The layered architecture is essential for understanding how operating systems boot and initialize. Think of it like building a house. You need the foundation before the walls and walls before the roof. Each layer of the OS depends on the services provided by the layer beneath it. During boot, the hardware layer initializes first, then the kernel layer loads, followed by system services, and finally the user interface. This sequential dependency means each layer must be fully operational before the next can start. It's not about being a single monolithic block or having equal peers. It's about organized hierarchy where lower layers support higher ones. 8. A database application experiences significant performance degradation when switching between reading and writing operations on the same file. Which I/O scheduling approach would minimize this overhead? A. Interrupt-driven transfers. B. Programmed I/O control. C. Direct memory access. D. Memory-mapped files. Do you know the answer? Correct answer, D. Memory-mapped files. Explanation. Option D is correct because memory-mapped files allow file contents to be accessed directly through memory addresses, eliminating the overhead of switching between read and write operations. Option A is incorrect because interrupt-driven transfers handle I/O completion notifications, but do not reduce the overhead of switching between read and write modes. Option B is incorrect because programmed I/O requires CPU involvement for every data transfer, actually increasing overhead rather than reducing it. Option C is incorrect because direct memory access reduces CPU overhead for data transfers but does not specifically address read-write switching overhead. Memory-mapped files are a powerful technique for improving database performance. Instead of using traditional read and write system calls, which involve copying data between kernel and user space, memory-mapped files make file contents appear directly in your program's address space. It's like having the file magically become part of your program's memory. When you access a memory address, you're actually accessing the file directly. This eliminates the overhead of constantly switching between read and write operations, because you just treat it like regular memory. The operating system handles syncing changes back to disk transparently. This is why databases love memory-mapped files. 9. A mobile device needs to extend battery life by reducing memory power consumption while maintaining application responsiveness. Which memory management technique best achieves this balance? A. Continuous allocation. B. Demand paging. C. Memory compaction. D. Fixed partitioning. Can you guess the answer? Correct answer, B. Demand paging. Explanation. Option B is correct because demand paging loads memory pages only when needed, reducing active memory usage and power consumption while maintaining application availability through virtual memory. Option A is incorrect because continuous allocation keeps all program memory resident at once, consuming more power than necessary for inactive portions. Option C is incorrect because memory compaction reorganizes memory to reduce fragmentation, but requires moving data, actually increasing power consumption temporarily. Option D is incorrect because fixed partitioning divides memory into static sections, potentially wasting memory and power on unused allocated space. Demand paging is a clever memory management technique that's perfect for power-constrained devices. Instead of loading an entire application into memory when it starts, demand paging only loads the pages you actually use. Think of it like a library, where instead of checking out every book at once, you only get the ones you need to read right now. When a mobile app starts, only the initial screen's code is loaded. As you navigate to different features, those pages are loaded on demand. This means less memory is actively powered, saving battery life. Pages that aren't being used can be swapped out to storage, further reducing power consumption. 10. Multiple processes need to coordinate their actions to complete a complex workflow without causing deadlocks. Which synchronization primitive provides both mutual exclusion and conditional waiting capabilities? A. Spin locks. B. Monitors. C. Semaphores. D. Barriers. Do you know the answer? Correct answer, B. Monitors. Explanation: option B is correct because monitors encapsulate shared data with synchronized methods and condition variables, providing both mutual exclusion and the ability to wait for specific conditions. Option A is incorrect because spin locks provide mutual exclusion through busy waiting, but lack condition variables for coordinated waiting, wasting CPU cycles. Option C is incorrect because semaphores provide basic synchronization, but don't encapsulate data or provide built-in condition variables for complex coordination. Option D is incorrect because barriers synchronize threads at specific points, but don't provide mutual exclusion or condition-based waiting for shared resources. Monitors are sophisticated synchronization constructs that combine the best of both worlds. A monitor is like a secure room that contains shared data and the procedures to access it, with a built-in bouncer at the door. Only one thread can be inside the monitor at a time, providing mutual exclusion automatically. But here's the powerful part. Monitors also include condition variables. These let threads wait for specific conditions without holding the lock. For example, a thread can wait inside the monitor until a buffer has space, then wake up automatically when another thread signals that condition. This combination of automatic mutual exclusion plus conditional waiting makes monitors perfect for complex coordination. 11. An embedded system with limited RAM needs to run programs larger than physical memory. Which combination of techniques would enable this while minimizing storage overhead? A. Segmentation with paging. B. Contiguous allocation only. C. Static linking only. D. Fixed partition allocation. Can you guess the answer? Correct answer, A. Segmentation with paging. Explanation: option A is correct because segmentation with paging combines logical program division with fixed-size memory blocks, enabling virtual memory support while maintaining efficient memory usage. Option B is incorrect because contiguous allocation requires entire programs to fit in continuous memory blocks, preventing execution of larger programs from running. Option C is incorrect because static linking includes all libraries at compile time, which actually increases program size rather than enabling larger programs. Option D is incorrect because fixed partition allocation divides memory into static sizes that cannot accommodate programs larger than physical memory. Segmentation with paging is a hybrid approach that solves the limited memory problem elegantly. Segmentation divides a program logically: code segment, data segment, stack segment, matching how programmers think about programs. Paging then breaks these segments into fixed-size chunks that can be scattered throughout physical memory. This combination means a program larger than physical memory can run because not all pages need to be in memory simultaneously. The segments provide logical organization, while paging provides the flexibility to use any available memory fragments. It's like having a large book divided into chapters, then each chapter split into pages that can be stored anywhere. 12. A multi-user system experiences a degraded performance when many users run similar applications simultaneously. Which memory optimization technique would best improve this situation? A. Memory defragmentation. B. Copy on write pages. C. Larger page sizes. D. Memory encryption. Do you know the answer? Correct answer, B. Copy on write pages. Explanation: Option B is correct because copy on write allows multiple processes to share identical memory pages until modification, significantly reducing memory usage when running similar applications. Option A is incorrect because memory defragmentation reorganizes free space but doesn't reduce the total memory required for multiple similar applications. Option C is incorrect because larger page sizes can increase internal fragmentation and do not address the redundancy of similar application data. Option D is incorrect because memory encryption provides security but actually increases overhead rather than optimizing memory usage for similar applications. Copy on write is a brilliant optimization technique for multi-user systems when multiple processes start the same application. Like a web browser, they initially share the same memory pages for common code and data. It's like multiple students sharing the same textbook. As long as they're just reading, one copy is enough. But here's the clever part. When a process tries to modify a shared page, the OS instantly creates a private copy just for that process. This happens transparently. The process doesn't even know it happened. This technique dramatically reduces memory usage because unmodified pages remain shared among all processes. Only the differences consume additional memory. 13. A development team needs to debug a crashed application by examining its state at the time of failure. Which operating system mechanism preserves this information for analysis? A. Context switching. B. Core dump creation. C. Process migration. D. Memory swapping. Can you guess the answer? Correct answer, B. Core dump creation. Explanation. Option B is correct because core dumps capture the complete memory image and register state of a crashed process, preserving all information needed for post-mortem debugging. Option A is incorrect because context switching saves process state for resumption, but doesn't preserve it permanently for debugging after a crash. Option C is incorrect because process migration moves running processes between systems, but doesn't capture crash state for debugging purposes. Option D is incorrect because memory swapping moves pages to disk for space management, but doesn't preserve complete process state after crashes. Core dumps are invaluable tools for post-mortem debugging. When a program crashes, the operating system captures a complete snapshot of the process's state at the exact moment of failure. This includes all memory contents, register values, stack traces, and heap data. It's like a crime scene photograph that preserves every detail for investigation. Developers can load this core dump into a debugger and examine variables, trace function calls, and see exactly what the program was doing when it crashed. Unlike logging, which only shows what you thought to record, a core dump captures everything, including data you didn't know would be important. 14. A file server must support both Windows and Linux clients accessing the same shared folders. Which file system feature enables this cross-platform compatibility? A. File compression. B. Journaling support. C. Virtual file system. D. File encryption. Do you know the answer? Correct answer, C. Virtual file system. Explanation. Option C is correct because virtual file system provides an abstraction layer that allows different file system implementations to be accessed through a common interface. Option A is incorrect because file compression reduces storage size but doesn't provide cross-platform compatibility between different operating system file formats. Option B is incorrect because journaling support provides crash recovery capabilities, but doesn't enable cross-platform file access between different systems. Option D is incorrect because file encryption provides security through data encoding but doesn't facilitate compatibility between different file system types. Virtual file systems are the key to cross-platform file sharing. The VFS acts as a translator between different file system implementations. When a Windows client using NTFS connects to a file server and a Linux client using ext4 connects to the same server, the VFS handles the differences. It presents a common API that both clients understand, regardless of their native file systems. The VFS translates file operations, handles different permission models, and manages naming conventions. It's like having a universal adapter that lets any plug work in any socket. This abstraction layer is what makes seamless file sharing possible across diverse operating systems. 15. An application experiences random crashes when multiple threads access shared data structures. Which debugging approach would most effectively identify the root cause? A. Memory leak detection. B. Race condition analysis. C. Stack trace examination. D. Network packet capture. Can you guess the answer? Correct answer, B. Race condition analysis. Explanation. Option B is correct because race condition analysis identifies timing-dependent bugs where multiple threads access shared data without proper synchronization, causing unpredictable behavior. Option A is incorrect because memory leak detection finds unreleased memory allocations, but doesn't identify problems with concurrent access to shared data. Option C is incorrect because stack trace examination shows the call sequence at crash time, but may miss the timing-dependent nature of race conditions. Option D is incorrect because network packet capture analyzes network traffic and is unrelated to thread synchronization issues within an application. The layered architecture is essential for understanding how operating systems boot and initialize. Think of it like building a house. You need the foundation before the walls and walls before the roof. Imagine two threads racing to update a shared variable. The final value depends on who wins the race. These bugs are notorious because they're non-deterministic. The program might work perfectly 1,000 times, then crash on the 1,001st. Race condition analysis tools track thread interactions, identify shared data access without proper synchronization, and highlight potential collision points. They can even artificially vary thread timing to expose hidden race conditions that might only occur under specific timing scenarios. 16. A multimedia streaming service needs to prioritize video packets over background downloads to maintain playback quality. Which kernel subsystem handles this differentiation? A. Process scheduler. B. I/O scheduler. C. Memory manager. D. File system. Do you know the answer? Correct answer, B. I/O scheduler. Explanation. Option B is correct because the I/O scheduler orders and prioritizes disk and network requests, allowing time-sensitive operations like video streaming to take precedence. Option A is incorrect because the process scheduler manages CPU time allocation between processes but does not directly prioritize network packet handling. Option C is incorrect because the memory manager handles RAM allocation and virtual memory but does not manage network packet priorities. Option D is incorrect because the file system manages data organization on storage devices but does not handle network packet prioritization. The I/O scheduler is the traffic controller for your system's data highways. When multiple processes request I/O operations simultaneously, like our streaming service needing video packets while background downloads run, the I/O scheduler decides who goes first. It can prioritize based on deadlines, giving video packets precedence because they're time sensitive. If a video packet arrives late, you see buffering or stuttering. But if a background download packet arrives late, nobody notices. The I/O scheduler understands these different quality of service requirements and reorders requests accordingly. It's managing not just disk access, but also network packet scheduling, ensuring smooth playback despite competing demands. 17. A security-critical application needs to ensure that sensitive data in memory cannot be accessed by other processes even after termination. Which protection mechanism addresses this requirement? A. Memory encryption. B. Access control lists. C. Memory scrubbing. D. Address randomization. Can you guess the answer? Correct answer, C. Memory scrubbing. Explanation: option C is correct because memory scrubbing overwrites memory contents with random data after deallocation, preventing sensitive information from being recovered by subsequent processes. Option A is incorrect because memory encryption protects data while in use, but does not necessarily clear it after process termination. Option B is incorrect because access control lists manage file permissions, but do not handle clearing of memory contents after process termination. Option D is incorrect because address randomization makes memory locations unpredictable for security, but does not clear sensitive data after use. Memory scrubbing is a critical security technique that prevents data leakage. When a process terminates, its memory isn't automatically cleared. It still contains all the sensitive data like passwords, encryption keys, or personal information. Memory scrubbing overwrites this memory with random data or zeros before it's allocated to another process. Think of it like shredding documents instead of just throwing them in the trash. Think of it like an emergency room. When a critical patient arrives, they don't wait in line, they get immediate attention. This deterministic behaviour is what makes RTOS perfect for automotive, aerospace, and medical devices. 18. A virtualization platform needs to run multiple operating systems simultaneously on a single physical machine. Which component manages hardware resource allocation between these systems? A. Device driver. B. Hypervisor. C. Bootloader. D. Shell interface. Do you know the answer? Correct answer, B. Hypervisor. Explanation: option B is correct because the hypervisor creates and manages virtual machines, allocating physical hardware resources among multiple operating systems running concurrently. Option A is incorrect because device drivers enable operating system communication with hardware, but do not manage resource allocation between multiple operating systems. Option C is incorrect because the bootloader initiates system startup, but does not manage ongoing resource allocation between multiple operating systems. Option D is incorrect because the shell interface provides user command interaction, but does not handle hardware, virtualization, or resource management. The hypervisor is the maestro conducting the virtual machine orchestra. It sits between the physical hardware and multiple operating systems, creating the illusion that each OS has its own dedicated machine. There are two types. Type 1 hypervisors run directly on hardware, while Type 2 run on top of a host OS. The hypervisor manages CPU scheduling between VMs, partitions memory so each VM has its isolated space, and virtualizes devices so multiple OSes can share the same physical hardware. It handles complex tasks like memory overcommitment and live migration. Without hypervisors, cloud computing as we know it wouldn't exist. 19. A distributed application needs to maintain data consistency across multiple nodes despite network failures. Which synchronization approach best ensures eventual consistency? A. Strict locking. B. Optimistic concurrency. C. Two-phase commit. D. Vector clocks. Can you guess the answer? Correct answer, D. Vector clocks. Explanation: option D is correct because vector clocks track causality in distributed systems, enabling conflict resolution and eventual consistency even when nodes temporarily lose connectivity. Option A is incorrect because strict locking requires continuous network connectivity and can cause deadlocks or system halts during network failures. Option B is incorrect because optimistic concurrency assumes conflicts are rare but doesn't provide a mechanism for ordering events across distributed nodes. Option C is incorrect because two-phase commit requires all nodes to be available and can block indefinitely during network partitions. Vector clocks are elegant solutions for distributed system synchronization. In a distributed system, there's no global clock, so determining the order of events across different nodes is challenging. Vector clocks solve this by giving each node its own logical clock that tracks events. When nodes communicate, they exchange their vector clock values, allowing them to establish causality. Did event A happen before event B, or were they concurrent? This is crucial for maintaining consistency when network partitions occur. Unlike strict locking, which requires constant connectivity, vector clocks allow nodes to work independently and reconcile later, achieving eventual consistency even with temporary failures. 20. An Internet of Things device with minimal storage needs to log sensor data continuously without running out of space. Which file system strategy best addresses this constraint? A. Circular buffering. B. File compression. C. Hierarchical storage. D. Indexed allocation. Do you know the answer? Correct answer, A. Circular buffering. Explanation: option A is correct, because circular buffering overwrites the oldest data when the storage fills up, maintaining continuous logging within fixed space constraints, which is typical of Internet of Things devices. Option B is incorrect because file compression reduces the size of the data but doesn't solve the fundamental problem of limited storage filling up over time. Option C is incorrect because hierarchical storage involves multiple storage tiers, which is impractical for minimal storage Internet of Things devices with single storage components. Option D is incorrect because indexed allocation organizes file blocks efficiently but doesn't address the continuous growth problem in limited space. Circular buffering is the perfect solution for continuous logging in resource-constrained IoT devices. Imagine a ring-shaped buffer where new data overwrites the oldest data when the buffer fills up. It's like a circular conveyor belt that never stops. When you reach the end, you seamlessly wrap around to the beginning. For an IoT sensor logging temperature every second, once the buffer fills, each new reading overwrites the oldest one. This guarantees you always have the most recent data without ever running out of space or needing to stop logging. The implementation is simple and efficient, requiring minimal processing power. 21. A compiler needs to prevent stack-based buffer overflow attacks in generated executables. Which memory protection technique should be implemented during code generation? A. Stack canaries. B. Heap allocation. C. Register spilling. D. Loop unrolling. Can you guess the answer? Correct answer, AA. Stack canaries. Explanation: option A is correct because stack canaries are guard values placed on the stack before the return address. They are checked before the function returns to detect buffer overflows. If the canary value has been altered, it indicates a buffer overflow attempt. Option B is incorrect because heap allocation manages memory dynamically on the heap, but it does not directly prevent stack-based buffer overflows. Option C is incorrect because register spilling is a compiler optimization technique that saves the contents of registers to memory when there are not enough registers available. It does not protect against buffer overflows. Option D is incorrect because loop unrolling is a compiler optimization technique that reduces loop overhead by replicating the loop body multiple times. It does not provide any protection against buffer overflows. Let's break down the core concept behind stack canaries and buffer overflow protection. Stack canaries are like the canaries miners use to detect poisonous gas. They're early warning systems. The compiler places a special guard value, called a canary, right before the return address on the stack. If a buffer overflow occurs and overwrites memory beyond its boundaries, it will overwrite the canary before reaching the return address. Before the function returns, the system checks if the canary is still intact. If it's been modified, the program immediately terminates rather than jumping to potentially malicious code. This simple technique has prevented countless security exploits. 22. A backup system needs to identify which files have changed since the last backup, without reading entire file contents. Which file system attribute enables this efficient detection? A. File permissions. B. Modification timestamp. C. File extension. D. Access frequency. Do you know the answer? Correct answer, B. Modification timestamp. Explanation. Option B is correct because modification timestamps record when files were last changed, allowing backup systems to quickly identify modified files without comparing actual content. Option A is incorrect because file permissions control access rights, but don't indicate whether file contents have been modified since last backup. Option C is incorrect because file extensions identify file types, but provide no information about when files were last modified or changed. Option D is incorrect because access frequency tracks how often files are read, but doesn't indicate whether contents have been modified. To really understand why modification timestamps are the correct choice, let's dive into efficient backup strategies. Every file in the system maintains metadata, including when it was last modified. This timestamp updates automatically whenever file contents change, creating a perfect change tracking mechanism. When the backup system runs, it simply compares each file's modification timestamp against the last backup time. Files modified after the last backup get included. Others are skipped. This is incredibly efficient because checking a timestamp takes microseconds, while reading and comparing entire file contents could take minutes. It's the difference between checking a package's shipping label versus opening and examining everything inside. 23. A mission-critical database server experiences occasional deadlocks between transactions. Which strategy would prevent deadlocks while maintaining system availability? A. Resource ordering. B. Process termination. C. Infinite waiting. D. Random backoff. Can you guess the answer? Correct answer, A. Resource ordering. Explanation. Option A is correct because resource ordering prevents circular wait by requiring all processes to request resources in the same predetermined order, eliminating the possibility of deadlock. Option B is incorrect because process termination resolves existing deadlocks but does not prevent them, potentially causing data loss and service disruption. Option C is incorrect because infinite waiting would cause the system to hang indefinitely when deadlocks occur, violating availability requirements. Option D is incorrect because random backoff helps with contention, but does not address the fundamental circular dependency that causes deadlocks. Resource ordering is a fundamental deadlock prevention strategy that eliminates circular wait entirely. Imagine all resources in your system are numbered. Database locks might be 1, file locks 2, network connections 3. The rule is simple but powerful. Every process must request resources in ascending numerical order. If you need resources 1 and 3, you must request 1 first, then 3. You can never request 3, then go back for 1. This makes circular dependencies impossible because there's no way for a cycle to form when everyone follows the same direction. It's like making all traffic flow one way on a circular road. No head-on collisions possible. 24. A mobile operating system needs to quickly switch between foreground and background applications while preserving battery life. Which process state transition accomplishes this most efficiently? A. New to terminated. B. Running to ready. C. Ready to waiting. D. Waiting to terminated. Do you know the answer? Correct answer, B. Running to ready. Explanation. Option B is correct because moving processes from running to ready state suspends execution while maintaining all process state in memory for quick resumption. Option A is incorrect because transitioning from new to terminated would skip execution entirely, not allowing the application to run at all. Option C is incorrect because ready to waiting transition occurs when processes need resources, not when switching between foreground and background. Option D is incorrect because waiting to terminated would destroy the process entirely, preventing it from resuming when brought to foreground. The running to ready state transition is crucial for mobile app switching. When you switch apps on your phone, the foreground app doesn't terminate. It transitions from running to ready state. This means the process gives up the CPU, but keeps all its data in memory. The program, counter, registers, and variables all remain intact, just suspended. When you switch back, the app transitions from ready to running, resuming exactly where it left off. This is much more battery efficient than terminating and restarting apps. The app stays warm in memory, ready to spring back to life instantly without the overhead of reloading everything from storage. 25. A cloud computing platform needs to isolate customer workloads while sharing physical hardware efficiently. Which CPU protection mechanism enables this secure multi-tenancy? A. Protection rings. B. Branch prediction. C. Cache coherence. D. Pipeline stages. Can you guess the answer? Correct answer, A. Protection rings. Explanation: Option A is correct because protection rings establish privilege levels that isolate user processes from kernel operations and each other, essential for secure multi-tenant environments. Option B is incorrect because branch prediction optimizes CPU performance by guessing instruction paths, but doesn't provide workload isolation or security. Option C is incorrect because cache coherence maintains data consistency across CPU caches, but doesn't isolate different customer workloads from each other. Option D is incorrect because pipeline stages improve instruction throughput through parallel execution, but don't provide security isolation between workloads. Protection rings are the foundation of secure multi-tenancy in cloud computing. Picture concentric circles like a bullseye target. Ring 0 at the center is the kernel with full hardware access. Ring 3 at the edge is where user applications run with minimal privileges. Customer workloads run in Ring 3, completely isolated from each other and the kernel. If a customer's application tries to access another customer's memory or execute privileged instructions, the CPU itself blocks it. This hardware-enforced isolation is much stronger than software-only solutions. Each ring can only access its own level and request services from inner rings through controlled gates called system calls. 26. An embedded router needs to handle network packets with minimal latency while running on limited hardware. Which interrupt handling approach best meets these requirements? A. Polling loops. B. Top-half processing. C. Software interrupts. D. Nested interrupts. Do you know the answer? Correct answer, B. Top-half processing. Explanation: Option B is correct because top-half processing handles time-critical, interrupt tasks immediately while deferring non-urgent work, minimizing latency for packet processing. Option A is incorrect because polling loops continuously check for events, wasting CPU cycles and increasing latency compared to interrupt-driven approaches. Option C is incorrect because software interrupts are triggered by programs rather than hardware events, adding unnecessary overhead for packet handling. Option D is incorrect because nested interrupts can cause stack overflow on limited hardware and increase complexity without improving packet latency. Top-half processing is an elegant solution for handling time-critical interrupts efficiently. When a network packet arrives, it triggers an interrupt that needs immediate attention. The top-half handler does only the absolute minimum, acknowledge the interrupt, copy the packet to a buffer, and schedule the bottom half for later. This typically takes microseconds. The heavy work like packet passing, protocol processing, and routing decisions happen in the bottom half when the system has more time. It's like an emergency room triage: stabilize immediately, treat thoroughly later. This split design ensures the router never misses packets due to spending too long processing previous ones. 27. A file system needs to recover quickly from unexpected power failures without losing recent changes. Which feature provides this crash consistency? A. File defragmentation. B. Journaling mechanism. C. File compression. D. Symbolic links. Can you guess the answer? Correct answer, B. Journaling mechanism. Explanation: option B is correct because journaling records intended changes before applying them, allowing file systems to replay or roll back operations after crashes for consistency. Option A is incorrect because file defragmentation reorganizes fragmented files for performance, but doesn't protect against data loss from power failures. Option C is incorrect because file compression reduces storage size but provides no protection or recovery mechanism for unexpected system crashes. Option D is incorrect because symbolic links create file references but don't provide any crash recovery or consistency guarantees. Journaling is the file system's insurance policy against crashes. Before making any changes to the file system, the journal records what it's about to do in a special log area. Each layer of the OS depends on the services provided by the layer beneath it. During boot, the hardware layer initializes first, then the kernel layer loads, followed by system services and finally the user interface. Without journaling, a crash during file write could leave the file system in an inconsistent state, partially updated with corrupted metadata. The journal ensures every operation is atomic. It either completes fully or not at all. 28. A high-performance computing cluster needs to share memory efficiently between processors with varying distances to memory banks. Which architecture addresses this non-uniform access pattern? A. Symmetric multiprocessing. B. NUMA architecture. C. Single core design. D. Pipeline architecture. Do you know the answer? Correct answer, B. NUMA architecture. Explanation: option B is correct because NUMA architecture accounts for varying memory access times based on processor-to-memory distance, optimizing performance in multiprocessor systems. Option A is incorrect because symmetric multiprocessing assumes uniform memory access times, not optimized for systems with varying memory distances. Option C is incorrect because single core design has only one processor, eliminating the multi-processor memory distance considerations entirely. Option D is incorrect because pipeline architecture refers to instruction execution stages within processors, not memory access patterns between processors. NUMA architecture addresses the reality that memory access isn't uniform in multiprocessor systems. In a NUMA system, each processor has local memory. It can access quickly, but can also access remote memory attached to other processors more slowly. It's like having your own desk drawer versus walking to a filing cabinet across the room. The operating system tries to allocate memory close to the processor that will use it most. This locality awareness can dramatically improve performance in high-performance computing. Database queries run faster when data is in local memory. Scientific computations process quicker with local data arrays. NUMA-aware scheduling and memory allocation are critical optimizations. 29. A containerization platform needs to provide process isolation without the overhead of full virtualization. Which kernel feature enables this lightweight isolation? A. Kernel modules. B. System calls. C. Namespaces. D. Device files. Can you guess the answer? Correct answer, C. Namespaces. Explanation, option C is correct because namespaces provide process isolation by creating separate views of system resources, enabling containers without full virtual machine overhead. Option A is incorrect because kernel modules extend kernel functionality dynamically but don't provide the process isolation required for containerization. Option B is incorrect because system calls interface between user programs and kernel but don't inherently provide isolation between processes. Option D is incorrect because device files represent hardware devices in the file system but don't provide process isolation capabilities. Namespaces are the secret sauce behind container technology. A namespace creates an isolated view of system resources for a process. It's like giving each container its own private universe where it thinks it's the only thing running on the system. The process namespace isolates process IDs. Network namespace provides separate network stacks. Mount namespace gives independent file system views. Unlike virtual machines that virtualize hardware, namespaces virtualize the operating system's view of resources. This is incredibly lightweight. No hypervisor overhead. No duplicate kernels. Containers share the host kernel but can't see or interfere with each other thanks to namespace isolation. 30. A solid-state drive controller needs to distribute writes evenly across memory cells to maximize device lifespan. Which technique accomplishes this wear distribution? A. Wear leveling. B. Bad block mapping. C. Error correction. D. Write caching. Do you know the answer? Correct answer, A. Wear leveling. Explanation, option A is correct because wear leveling distributes write operations evenly across all flash memory cells, preventing premature failure from concentrated writes. Option B is incorrect because bad block mapping tracks and avoids failed memory blocks but doesn't prevent wear by distributing writes evenly. Option C is incorrect because error correction detects and fixes data corruption, but doesn't address the physical wear distribution across memory cells. Option D is incorrect because write caching buffers write operations for performance, but doesn't ensure even distribution across memory cells. Wear leveling is essential for SSD longevity because flash memory cells can only handle a limited number of write cycles. Without wear leveling, frequently updated data would burn out specific cells while others remain unused. The SSD controller tracks write counts for each cell and spreads writes evenly across all available cells. It's like rotating crops in farming, using different fields each season to prevent soil exhaustion. When you update a file, the controller writes it to the least used cells, not the same location. Even static data gets moved periodically to free up low-wear cells for active use. This technique can extend an SSD's life from months to decades. 31. An operating system needs to prevent malicious programs from accessing kernel memory directly. Which hardware feature enforces this separation? A. Translation look-aside buffer. B. Memory management unit. C. Cache controller. D. Arithmetic logic unit. Can you guess the answer? Correct answer, B. Memory management unit. Explanation, option B is correct because the memory management unit enforces memory protection by translating virtual addresses and checking access permissions for each memory reference. Option A is incorrect because the translation look-aside buffer caches address translations for speed but doesn't enforce protection, only accelerates lookups. Option C is incorrect because the cache controller manages CPU cache operations for performance but doesn't enforce memory access restrictions. Option D is incorrect because the arithmetic logic unit performs mathematical operations and has no role in memory protection or access control. The memory management unit is your system's security guard for memory access. The MMU is hardware that sits between the CPU and physical memory, checking every single memory access. When a program tries to read or write memory, the MMU translates the virtual address to a physical address and checks permissions. If a malicious program tries to access kernel memory, the MMU sees it doesn't have permission and triggers a protection fault. Your applications don't need to know or care about the underlying differences. They just see one big storage space, even though behind the scenes the VFS is managing the complexity of multiple servers and file systems. 32. A video game needs to maintain smooth frame rates while loading new level assets in the background. Which process scheduling characteristic best supports this requirement? A. Preemptive multitasking. B. Cooperative scheduling. C. Batch processing. D. Priority inversion. Do you know the answer? Correct answer. A. Preemptive multitasking. Explanation: option A is correct because preemptive multitasking allows the scheduler to interrupt background loading to maintain foreground rendering priority, ensuring smooth frame rates. Option B is incorrect because cooperative scheduling relies on processes voluntarily yielding control, which could cause frame drops during asset loading. Option C is incorrect because batch processing executes jobs sequentially without interactivity, incompatible with real-time gaming requirements. Option D is incorrect because priority inversion is a problem where low-priority tasks block high-priority ones, degrading rather than improving performance. Preemptive multitasking is why modern games can load assets without freezing. With preemptive multitasking, the operating system can forcibly interrupt any running process to give CPU time to others. Your game's render thread runs at high priority, drawing frames 60 times per second. Meanwhile, asset loading runs at lower priority in the background. The scheduler interrupts the loader whenever the renderer needs CPU time, ensuring smooth frame rates. The beauty is that neither process needs to cooperate. The OS enforces sharing. Without preemption, the loader could monopolize the CPU until it finishes, causing visible stuttering. Preemption guarantees responsive foreground performance. 33. A distributed file system needs to maintain consistency when multiple clients modify the same file simultaneously. Which locking strategy minimizes performance impact? A. Mandatory locking. B. Advisory locking. C. Granular locking. D. Exclusive locking. Can you guess the answer? Correct answer: C. Granular locking. Explanation: option C is correct because granular locking allows different parts of a file to be locked independently, enabling concurrent access to non-overlapping regions. Option A is incorrect because mandatory locking enforces locks at the kernel level, which can cause unnecessary blocking and does not minimize performance impact. Option B is incorrect because advisory locking requires voluntary cooperation, which does not guarantee consistency if clients do not respect lock requests. Option D is incorrect because exclusive locking prevents all concurrent access to entire files, creating bottlenecks and significantly reducing system performance. Granular locking revolutionizes concurrent file access in distributed systems. Instead of locking entire files, granular locking allows different parts of a file to be locked independently. Imagine a large spreadsheet where user A edits rows 1 through 10, while user B works on rows 50 through 60. With granular locking, both can work simultaneously because they're accessing different regions. Each lock covers a specific byte range within the file. The system maintains a lock table tracking, which ranges are locked by whom. This dramatically improves performance in collaborative environments. Database systems use similar techniques, locking individual records rather than entire tables. 34. A smartphone operating system needs to terminate background applications when memory runs low. Which component makes these resource management decisions? A. Bootloader. B. Out-of-memory killer. C. Garbage collector. D. Package manager. Do you know the answer? Correct answer, B. Out-of-memory killer. Explanation: option B is correct because the out-of-memory killer selectively terminates processes when system memory is exhausted, prioritizing less important background applications. Option A is incorrect because the bootloader initializes system startup but doesn't manage runtime memory or make process termination decisions. Option C is incorrect because garbage collectors reclaim unused memory within applications but don't terminate entire processes for system memory management. Option D is incorrect because package managers install and remove software packages but don't make runtime decisions about process termination. The out-of-memory killer is Android's survival mechanism when RAM runs critically low. It's like a lifeboat operator who must decide who to throw overboard when the boat is sinking. The OM killer assigns scores to processes based on their importance and memory usage. Foreground apps get low scores, cached apps get high scores. When memory pressure hits critical levels, it terminates the highest scoring processes first. Your music player in the background might survive while that weather app you opened yesterday gets killed. The algorithm considers factors like user visibility, service importance, and recent usage. It's ruthless but necessary for system stability. 35. A network file server experiences performance degradation when many clients request different files simultaneously. Which disk scheduling algorithm would minimize seek time overhead? A. First come, first served. B. Shortest seek time first. C. Deadline scheduling. D. Random access. Can you guess the answer? Correct answer, B. Shortest seek time first. Explanation: option B is correct because shortest seek time first minimizes disk head movement by servicing requests closest to current position, reducing mechanical overhead. Option A is incorrect because first come, first served processes requests in arrival order, potentially causing excessive head movement between distant sectors. Option C is incorrect because deadline scheduling prioritizes request age over seek distance, potentially increasing total head movement for performance. Option D is incorrect because random access describes a capability rather than a scheduling algorithm and would cause inefficient disk head movement. Shortest seek time first is the disk scheduling algorithm that minimizes mechanical movement. Hard drives have physical read heads that must move across spinning platters. This movement, called seeking, is the slowest part of disk access. SSTF services request closest to the current head position first, regardless of arrival order. If the head is at track 50 and requests come for tracks 10, 45 and 90, it serves 45 first because it's nearest. This minimizes total head movement and maximizes throughput. It's like a taxi driver picking up the nearest passenger first, not the one who called earliest. The trade-off is potential starvation for distant requests. 36. An enterprise storage system needs to detect and correct data corruption without user intervention. Which redundancy technique provides automatic error recovery? A. RAID mirroring. B. Parity checking. C. Checksums only. D. Manual backups. Do you know the answer? Correct answer, A. RAID mirroring. Explanation: option A is correct because RAID mirroring maintains identical copies on multiple drives, automatically serving data from good copies when corruption is detected. Option B is incorrect because parity checking can detect errors and reconstruct data but requires additional processing and is not an automatic recovery. Option C is incorrect because checksums only detect corruption, but cannot correct errors without additional redundant data for reconstruction. Option D is incorrect because manual backups require human intervention to restore data and do not provide automatic recovery from corruption. RAID mirroring provides automatic error recovery through complete redundancy. In RAID 1, every piece of data is written to 2 or more drives simultaneously. It's like having a backup singer who knows every word. If the lead singer loses their voice, the show goes on without interruption. When the system detects corruption on one drive through checksums, it immediately serves the data from the mirror drive. No reconstruction needed, no calculations required, just instant failover to the good copy. This automatic recovery happens transparently to applications. The cost is double the storage, but for critical data, that instant recovery capability is invaluable. 37. A real-time audio processing application experiences glitches when garbage collection pauses execution. Which memory management approach would eliminate these interruptions? A. Reference counting. B. Mark and sweep. C. Manual management. D. Generational collection. Can you guess the answer? Correct answer, C. Manual management. Explanation. Option C is correct because manual memory management gives complete control over allocation and deallocation timing, eliminating unpredictable garbage collection pauses. Option A is incorrect because reference counting still causes pauses when circular references are collected or when many objects are freed simultaneously. Option B is incorrect because mark and sweep garbage collection requires stopping program execution to trace reachable objects, causing audio glitches. Option D is incorrect because generational collection reduces but doesn't eliminate collection pauses, still causing potential interruptions in real-time audio. Manual memory management eliminates garbage collection pauses entirely for real-time audio. With manual management, the programmer explicitly allocates and frees memory using malloc and free or new and delete. You control exactly when memory operations happen, scheduling them during silent periods or between audio buffers. There's no garbage collector that might suddenly decide to clean up while you're processing audio samples. Professional audio software often pre-allocates all needed memory up front, then reuses those buffers continuously. This deterministic behavior is why recording studios rely on manually managed code. The trade-off is increased complexity and the risk of memory leaks. 38. A print spooler needs to manage multiple print jobs from different users while maintaining order and priority. Which data structure best supports these requirements? A. Priority queue. B. Hash table. C. Binary tree. D. Linked list. Do you know the answer? Correct answer, A. Priority queue. Explanation. Option A is correct because priority queues maintain elements sorted by priority while preserving insertion order for equal priorities, ideal for print job management. Option B is incorrect because hash tables provide fast lookup but don't maintain ordering or priority relationships between print jobs. Option C is incorrect because binary trees can maintain sorted order but don't naturally handle priority levels with first in, first out ordering within priorities. Option D is incorrect because linked lists maintain insertion order but don't support efficient, priority-based job selection without additional complexity. Priority queues are perfect for print spoolers because they handle both urgency and fairness. A priority queue maintains elements sorted by priority, but within each priority level it preserves first in, first out order. Imagine executive print jobs get priority 1, regular users get priority 2, and bulk reports get priority 3. All priority 1 jobs print before priority 2, but among priority 1 jobs they print in arrival order. This prevents important documents from waiting behind large reports, while ensuring fairness within each priority class. The queue automatically maintains this ordering as new jobs arrive. It's the best of both worlds, priority and fairness. 39. A laptop needs to preserve running applications during sleep mode while minimizing battery drain. Which power management technique achieves this balance? A. Complete shutdown. B. Suspend to RAM. C. Hibernate to disk. D. Screen blanking. Can you guess the answer? Correct answer, B. Suspend to RAM. Explanation: option B is correct because suspend to RAM maintains system state in memory with minimal power usage, enabling instant resume while preserving application state. Option A is incorrect because complete shutdown terminates all applications and requires a full system restart, losing all running application state. Option C is incorrect because hibernate to disk save state, but requires longer resume times and doesn't maintain instant availability. Option D is incorrect because screen blanking only turns off display output without significantly reducing system power consumption or preserving battery. Suspend to RAM strikes the perfect balance for laptop power management. When you close your laptop lid, the system stops executing code but keeps all data in memory, which requires minimal power, just enough to refresh the RAM. The CPU, disk and screen completely power down. It's like putting your work desk in a time freeze. Everything stays exactly where it was. When you open the lid, the system resumes in seconds because everything is already in memory. Unlike hibernate, which writes everything to disk and takes longer to resume, or shutdown, which loses all state, suspend to RAM provides instant availability with minimal battery drain. 40. A web browser needs to isolate JavaScript execution from different websites to prevent cross-site attacks. Which process architecture provides this security boundary? A. Single process model. B. Process per site. C. Thread per tab. D. Shared memory model. Do you know the answer? Correct answer, B. Process per site. Explanation: option B is correct because process per site isolation creates separate address spaces for different origins, preventing malicious code from accessing other sites' data. Option A is incorrect because the single process model runs everything in one address space, providing no isolation between different websites' code. Option C is incorrect because thread per tab shares memory within the same process, which is insufficient for preventing cross-site security attacks. Option D is incorrect because the shared memory model explicitly allows memory access between components, the opposite of the required security isolation. Process per site isolation is the cornerstone of modern browser security. Each website origin runs in its own separate process with its own address space. When you have Gmail, Facebook, and a banking site open, they're completely isolated from each other at the operating system level. If malicious JavaScript on one site tries to read memory from another site's tab, it literally cannot because they're in different processes. The OS enforces this boundary. Even if one site crashes or gets compromised, the others continue running safely. This architecture prevents entire classes of attacks, like Spectre and Meltdown, from crossing site boundaries. It's security through OS-enforced isolation. 41. A version control system needs to track file changes efficiently without storing complete copies for each revision. Which storage technique minimizes space usage? A. Full backups. B. Delta compression. C. File duplication. D. Sector copying. Can you guess the answer? Correct answer, B. Delta compression. Explanation: option B is correct because delta compression stores only the differences between versions, dramatically reducing storage requirements while maintaining complete version history. Option A is incorrect because full backups store complete copies of all files for each version, consuming maximum storage space. Option C is incorrect because file duplication creates complete copies for each version, providing no space savings compared to storing differences. Option D is incorrect because sector copying duplicates disk sectors regardless of actual changes, wasting space on unchanged data. Delta compression is the secret behind efficient version control systems. Instead of storing complete copies of files for every version, delta compression stores only the differences between versions. Imagine editing a 1,000-line document and changing just 3 lines. Delta compression saves only those 3 changed lines, plus instructions on where they go. It's like keeping a recipe for transforming version 1 into version 2, rather than keeping both complete versions. Git, Subversion, and other version control systems use this technique extensively. A repository with hundreds of versions might use less space than storing just 2 complete copies. This makes version control practical, even for large projects with extensive history. 42. A microservices architecture needs to handle service failures gracefully without affecting other services. Which fault isolation mechanism provides this resilience? A. Global error handling. B. Process boundaries. C. Shared libraries. D. Common memory pool. Do you know the answer? Correct answer, B. Process boundaries. Explanation: option B is correct because process boundaries isolate failures within individual services, preventing crashes from propagating to other services in the architecture. Option A is incorrect because global error handling attempts to catch all errors but cannot prevent memory corruption or resource leaks affecting other services. Option C is incorrect because shared libraries create dependencies where bugs in libraries can crash all services using them simultaneously. Option D is incorrect because common memory pools allow corruption in one service to affect others sharing the same memory space. Process boundaries provide bulletproof fault isolation in microservices architectures. Each microservice runs in its own process with completely separate memory space. When one service crashes due to a null pointer or memory corruption, it's like a fuse blowing in one room while the rest of the house stays powered. The crashed process simply disappears, but other services continue running unaffected. The operating system enforces these boundaries at the hardware level through memory protection. A bug in the payment service can't corrupt the inventory service's data because they literally cannot access each other's memory. This isolation is why companies like Netflix can update services independently without bringing down the entire platform. 43. A batch processing system needs to maximize throughput for scientific computations without user interaction. Which scheduling policy best serves this workload? A. Interactive priority. B. Shortest job first. C. Real-time scheduling. D. Fair share. Can you guess the answer? Correct answer, B. Shortest job first. Explanation: option B is correct because shortest job first maximizes throughput by completing more jobs quickly, which is ideal for batch systems where response time is not critical. Option A is incorrect because interactive priority optimizes for user responsiveness rather than throughput, which is unnecessary for batch processing without users. Option C is incorrect because real-time scheduling ensures deadline compliance rather than throughput maximization, adding unnecessary overhead for batch jobs. Option D is incorrect because fair share divides resources equally among users, but does not maximize overall system throughput for batch workloads. Shortest job first maximizes throughput in batch processing systems where all jobs are known up front. SJF completes more jobs per unit time by handling quick jobs first. Think of a grocery checkout where someone with 50 items lets people with 2 items go first. More customers get served faster overall. In scientific computing, if you have jobs taking 1 hour, 5 hours and 10 minutes, running the 10-minute job first means one job completes quickly, while barely delaying the others. This creates better average turnaround time and higher user satisfaction. The key insight is that short jobs suffer disproportionately when waiting behind long jobs, while long jobs barely notice short delays. 44. An antivirus program needs to scan files before allowing access without significantly impacting system performance. Which file system integration point enables this? A. File filter driver, B. Boot sector hook, C. Registry modification, D. User mode library. Do you know the answer? Correct answer, A. File filter driver. Explanation. Option A is correct because file filter drivers operate at the kernel level, allowing them to intercept file operations before they reach the user, which provides transparent scanning with minimal performance impact. Option B is incorrect because boot sector hooks are only active during system startup and cannot monitor or intercept file access during runtime. Option C is incorrect because registry modifications change system settings, but do not provide a mechanism for intercepting file access operations. Option D is incorrect because user mode libraries require applications to use them explicitly, leaving the system vulnerable if an application bypasses the library. File filter drivers operate at the perfect interception point for antivirus scanning. A filter driver sits in the kernel between applications and the file system, seeing every file operation before it completes. When any program tries to open a file, the request passes through the filter driver first. The antivirus filter driver can scan the file, check its signature against malware databases, and either allow or block access. This happens transparently. Applications don't even know they're being protected. Because it's in the kernel, it's impossible for malware to bypass. Every file access, whether from system processes or user applications, must pass through this checkpoint. 45. A desktop environment needs to provide smooth window animations while running computationally intensive background tasks. Which component ensures visual responsiveness? A. Window compositor, B. Task manager, C. System monitor, D. Resource meter. Can you guess the answer? Correct answer, A. Window compositor. Explanation. Option A is correct because the window compositor manages display rendering with high priority, ensuring smooth animations regardless of background computational load. Option B is incorrect because task managers display process information but don't control rendering priority or ensure animation smoothness. Option C is incorrect because system monitors track resource usage but don't actively manage display rendering or animation priorities. Option D is incorrect because resource meters measure system utilization but have no role in maintaining visual responsiveness or animation quality. The window compositor is the maestro, ensuring smooth visual performance on your desktop. It manages all window rendering with dedicated high priority, separate from application processing. Think of it as a film director who ensures smooth scene transitions regardless of what actors are doing backstage. The compositor uses GPU acceleration to blend windows, apply transparency effects, and animate transitions. Even if a background process is consuming 100% CPU calculating prime numbers, the compositor's priority ensures your windows still animate smoothly. It maintains a separate rendering pipeline that's independent of application responsiveness. Modern desktops feel fluid because the compositor never stops conducting the visual orchestra. 46. A database system experiences thrashing when too many concurrent queries execute simultaneously. Which resource management technique would prevent this performance collapse? A. Memory over commit, B. Admission control, C. Infinite buffering, D. Unrestricted access. Do you know the answer? Correct answer, B. Admission control. Explanation. Option B is correct because admission control limits concurrent query execution based on available resources, preventing thrashing by maintaining workload within system capacity. Option A is incorrect because memory over commit allows allocating more memory than physically available, potentially worsening thrashing when limits are reached. Option C is incorrect because infinite buffering would consume all available memory for buffers, exacerbating rather than preventing thrashing conditions. Option D is incorrect because unrestricted access allows unlimited concurrent queries, directly causing the thrashing problem being experienced. Admission control prevents system thrashing by acting as a bouncer at the database door. When too many queries run simultaneously, they compete for memory, causing excessive paging that brings performance to a crawl. Admission control monitors system resources and only allows new queries when sufficient resources exist. It's like a restaurant that stops seating new customers when the kitchen is overwhelmed. Queries wait in a queue rather than all trying to execute at once. By keeping the active workload within system capacity, each admitted query runs efficiently. 10 queries running well is better than 50 queries thrashing. This prevention is far superior to trying to recover after thrashing begins. 47. A network driver needs to handle high packet rates without overwhelming the CPU with interrupts. Which technique reduces interrupt overhead? A. Interrupt coalescing. B. Priority boosting. C. Context switching. D. Signal amplification. Can you guess the answer? Correct answer A. Interrupt coalescing. Explanation. Option A is correct because interrupt coalescing combines multiple interrupts into a single interrupt, reducing the number of times the CPU has to stop what it's doing and handle a new interrupt. Option B is incorrect because priority boosting is a method to increase the importance of a process or thread, not reduce interrupts. Option C is incorrect because context switching is the process of storing and restoring the state of a CPU so that execution can be resumed from the same point later, and it increases overhead. Option D is incorrect because signal amplification is related to strengthening electrical signals, not managing CPU interrupts. Interrupt coalescing dramatically reduces CPU overhead in high-speed networking. Without coalescing, a gigabit network card could generate thousands of interrupts per second, each requiring CPU context switches. Interrupt coalescing batches multiple packets into a single interrupt. Instead of interrupting for every packet, the network card waits until several packets arrive, or a timer expires, then generates one interrupt for the entire batch. It's like a mail carrier waiting to collect multiple letters before making one trip instead of running back for each letter. This reduces interrupt overhead from consuming 30% of CPU to under 5%, leaving more cycles for actual packet processing. 48. A multi-core processor system shows poor performance despite low individual core utilization. Which scheduling issue likely causes this inefficiency? A. Core affinity. B. Load imbalance. C. Hyperthreading. D. Clock speed. Do you know the answer? Correct answer B. Load imbalance. Explanation. Option B is correct because load imbalance concentrates work on a few cores while others remain idle, causing poor overall performance despite available processing capacity. Option A is incorrect because core affinity keeps processes on specific cores for cache efficiency and generally improves rather than degrades performance. Option C is incorrect because hyperthreading increases thread execution, capacity per core, and typically improves rather than reduces system performance. Option D is incorrect because clock speed affects all cores equally and would not explain uneven utilization patterns across different cores. Load imbalance explains why multi-core systems can perform poorly despite available capacity. When work isn't distributed evenly, some cores work at maximum capacity while others sit idle. Imagine a restaurant with 4 chefs where all orders go to one chef while 3 stand around. The kitchen has capacity, but customers still wait. In computing, this happens when threads have affinity to specific cores or when the scheduler doesn't actively balance work. One core might handle all network interrupts while others are underutilized. The solution involves active load balancing, migrating threads between cores to equalize work. Modern schedulers constantly monitor and rebalance to prevent this inefficiency. 49. A security audit reveals sensitive data, persisting in swap files after application termination. Which security measure prevents this information leakage? A. Swap encryption. B. File permissions. C. Access logs. D. Network firewall. Can you guess the answer? Correct answer, A. Swap encryption. Explanation: option A is correct because swap encryption protects data written to swap files, preventing recovery of sensitive information from disk even after process termination. Option B is incorrect because file permissions control who can access swap files, but do not prevent administrators or forensic tools from reading data. Option C is incorrect because access logs record who accessed files, but do not prevent sensitive data from being readable in swap files. Option D is incorrect because network firewalls protect network traffic, but have no relevance to local swap file data protection. Swap encryption is essential for protecting sensitive data that spills to disk during normal operation. When RAM fills up, the operating system writes memory pages to swap files on disk. Without encryption, sensitive data like passwords, encryption keys, and personal information sits readable on the disk even after the program terminates. Swap encryption automatically encrypts pages before writing to disk using a key stored only in memory. Even if someone steals your hard drive or analyzes swap files with forensic tools, they see only encrypted gibberish. The decryption happens transparently when pages are loaded back to RAM. This closes a critical security hole that many systems overlook. 50. A development environment needs to test software on multiple operating system versions without maintaining separate physical machines. Which virtualization approach provides maximum flexibility? A. Hardware emulation. B. Full virtualization. C. Paravirtualization. D. Container isolation. Do you know the answer? Correct answer, B. Full virtualization. Explanation: option B is correct because full virtualization runs unmodified operating systems with complete hardware abstraction, providing maximum flexibility for testing different OS versions. Option A is incorrect because hardware emulation simulates different CPU architectures with significant performance overhead, unnecessary for same architecture operating system testing. Option C is incorrect because paravirtualization requires modified operating systems, limiting flexibility to test standard unmodified operating system versions. Option D is incorrect because container isolation shares the host kernel, preventing testing of different operating system versions or kernels. Full virtualization provides maximum flexibility for testing different operating systems because it creates complete virtual hardware environments. Unlike containers that share the host kernel, full virtualization emulates an entire computer system. You can run Windows, Linux, FreeBSD, or any OS that supports your virtual hardware completely unmodified. The guest operating systems don't know they're virtualized. They think they're running on real hardware. This allows testing exact production configurations, different kernel versions, and even different architectures. The hypervisor handles the translation between virtual and physical resources. While there's performance overhead compared to containers, the ability to run any unmodified OS makes it indispensable for comprehensive testing. You have reached the end of our first question set. For the free complete exam preparation, visit our website link in the description, where you find thousands more practice questions and comprehensive study guides. Thanks for studying with us today. See you in the next video.